As you've learnt in previous courses, there are 4 different types of data. We can have nominal data, also known as categorical data. We can have ordinal data. We can have interval data, and we can have ratio data. Whenever we're dealing with frequency counts, so in other words categorical data and sometimes ordinal data, but whenever we're dealing with frequency counts, we are dealing with, when we're categorizing into certain groups, so the number of Toyotas that come past and we're tapping off how many number of Toyotas there are, or the number of Porsches, or the number of Holdens, we're dealing with categorical data. And to analyse categorical data, we need to use a chi-squared. What we're looking at today is what is a chi-squared, or in more particularity, what is a one-way chi-squared. We're looking at how to calculate the expected frequencies in a chi-squared. I'll look at some of the assumptions of a chi-squared, and also interpreting the SPSS output. So imagine a psychology class is in deep discussion about the methods of advertising alcohol towards young people. As the class ended, the topic was focused on people's attitudes as to whether alcohol advertising influenced the purchasing decision of young people. It was clear that there was strong disagreement about whether advertising to minors had an effect or not. Both sides of the argument declared that educated people supported their position. Now, a couple of people left the class determined to get actual advertising data, or data on alcohol advertising and purchasing by young people. They collected data on alcohol purchases by young people at bottle shops. The researchers find the following numbers of purchases by teenagers at bottle shops over the last week. Now, when they looked at the data, the general conclusion of the class was that it looked like advertising might have an effect, especially exciting advertising on the purchasing decision of youngsters. Maybe, said another student, and maybe not. It looks like a difference, but maybe the difference is just the usual variation you find in samples. So here we can see that there's either a difference or not a difference in the amount of alcohol purchases in each of the different categories. So in other words, frequency data. So in the usual terminology of psychology statistics, the null hypothesis is that there's no difference across the categories compared to the expected frequency. So the null hypothesis is that there's no difference in the population in the number of bottles purchased across each type of advertising. In other words, the proportions are equal. So the probability of getting absolute bore is equal to the probability of absolute colour, and the probability of is equal to the probability of getting absolute excite, so which is equal to 0.333, 1/3. So the alternate hypothesis is that there is a difference in the categories. So the alternate hypothesis would be along the lines, there is a difference in the population in the number of bottles purchased across each type of advertising. In other words, there is a difference. There is a real no chance difference. The 3 proportions are not equal. To answer this question, we need to do a chi-square statistic on goodness of fit, which examines a frequency against some expected frequency. Now, previously you might have done t-tests and ANOVAs, and the data may have been on attitudes, IQ, time, response times. These numbers are interval or ratio level data. The chi-squared is useful for nominal or categorical data. Now, the chi-squared is an incredibly useful statistic. What it does is it tests whether one set of proportions is different from another. And it does this by comparing frequencies. We use a chi-square when we want to know whether the data is similar to an expected frequency. For example, is there a difference in the number of car accidents at different intersections? For example, at traffic lights, at roundabouts, stop signs, or give-way signs. So the researcher could select a sample of 20 traffic lights, 20 roundabouts, 20 stop signs, and 20 give-way signs. Then count the number of accidents that occur at each type of intersection over 12 months. The null hypothesis here would be that there's no difference in the population in the number of accidents across each type of intersection. So in other words, the proportions are equal. So in other words, the proportion of an accident at the traffic lights is equal to the proportion or the probability at roundabouts and at stop signs and at give-way signs, which is equal to 1/4 or 0.25. The alternative hypothesis, there is a difference in the population in the number of accidents across each type of intersection. In other words, there's a real no chance difference. The 4 proportions are not equal. Or we could take a vote on people's preference for abolishing free access to medical services. We take a representative sample of Australians who can choose yes, maybe, or no. So they get categorised into yes, maybe, or no. We could then use the chi-squared to see if there's a difference in the proportion of occurrence across each category. The null hypothesis might be that there's no difference in the population in voting preferences to abolish free medical services. So the proportions are equal, 1/3 each. Proportion of yes, maybe, and no equal to 1/3. Or the alternative hypothesis is that there is a difference in the population in the number of people in each category, i.e. there is a real no chance difference. The three proportions are not equal. Now these are examples in which the hypothesized frequencies are equal. In other words, all categories will have a similar number of members. But what about when the hypothesized frequencies are not all equal? An early hypothesis about schizophrenia was that it was a simple genetic cause. In accordance with this theory, 1/4 or a 1:3 ratio of offspring of selected group of parents would be expected to be diagnosed as schizophrenic. Suppose that you had 200 offspring and 19% of them had schizophrenia. You could use a chi-square goodness of fit to test this 1:3 ratio. The null hypothesis might be that there is no difference in the population of offspring of parents who have schizophrenia compared to the theory that the proportions are equivalent to 25% and 75%. The alternative hypothesis is that there is a difference in the population of offspring of parents who have schizophrenia compared to the theory. In other words, there's a real no chance difference to the proportions of 25% and 75%. Okay, so I've explained what a chi-square is and how it can be used. Let's now go back to the example of advertising of alcohol to the teenage market.